Find the perimeter of the irregular object below. So in this image we have a rectangle and a triangle kind of pieced together. So let's write down what we know. So if one side of the rectangle is 16, then the opposite side is going to be 16. And if the other side of the rectangle is 24, the opposite side is going to be 24. So now we have all the sides of the rectangle. We need to find all the sides of the triangle. And luckily for us, it's a right triangle, so we can use the Pythagorean theorem to find x. So here's the Pythagorean theorem. We're going to have x is going to go for c because that is opposite the right angle, so that should be the longest side. So I'm going to put in x here for c and 12 and 16 for a and b. So 16 squared is 256, 12 squared is 144. We're going to add those two together and we get x squared equals 400. We take the square root of 400, which we're going to break it down into its factors. 100 times 4, 100 is 10 times 10, and 4 is 2 times 2. So we can pull out a 10 and a 2 to give us 20 centimeters. Then we want to identify a spot on the perimeter to start. So I'm going to put a red dot here, and I'm going to go around the entire figure. So the perimeter is going to be 16 plus 24 plus 20 plus 12 plus 24. I'm going to add up 16 and 24 to get 40. Bring down the 20, and 12 plus 24 gives me 36. Add 40 and 20 gives me 60, and 60 plus 36 is 96 centimeters. Let's find the perimeter of another rectangle. So we're going to use the Pythagorean theorem to find the perimeter. So first thing we need to do is find x. Let's write out the formula for the Pythagorean theorem. Plug in our givens. 13 is opposite the right angle, so that should go in for c here as the hypotenuse. So we have x squared plus 12 squared, which is 144, and 13 squared is 169. We subtract 144 from both sides, and we get x squared equals 25. We take the square root of 25, which is 5 times 5 under the square root, and we can take out a 5. We're going to plug in what we know. So I'm going to replace x with 5, plug in a 5 across the other side, and a 12 across the other side, add up all the sides, and we get 10 plus 24, which equals 34 units. Another thing that we need to look at is Pythagorean triples. This is another way to solve special right triangles that are all the sides are going to be whole numbers. We'll look more into this into the class. I just kind of want to give you an intro to it, so if you don't understand this perfectly when we're done, that's fine. We're going to go over it again in class. So a Pythagorean triple is a set of 3 positive integers, a, b, and c, that satisfy the equation a squared plus b squared equals c squared. Here are the most common Pythagorean triples. It's 3, 4, and 5. Gives you a perfect right triangle with all whole numbers. Another one is 5, 12, and 13. 8, 17, and 15. 7, 25, 24. And I believe that says 9, 41, and 40. We'll go back over that if I'm wrong. So what would happen with these is, if we, for instance, let's take the 5, 12, 13 triangle. If I multiplied each side by 2, that would also be a Pythagorean triple. So if it was 10, 26, and 24, that would also satisfy the equation a squared plus b squared equals c squared. Alright, let's look at an example. Find the length of a hypotenuse of a right triangle using 2 methods. Should say right triangle, ignore that. Alright, method 1 is what we already know. That's a squared plus b squared equals c squared. We're going to plug in our givens, square the 2 legs, add 576 plus 1024 to get 1600. Take the square root. So we get 16 times 100, break it down even further. So we have 2 sets of 4 and 2 sets of 10. I can take out a 4 and 10 to get x equals 40. So that's the first method to solve that. That's fine if you want to use that, but I want to show you a second one. Second one is we take the triangle and break it up into its factors. So 24 is 8 times 3, and 32 is 8 times 4. If you notice, there's a 4 and a 3 in this common factor of 8. So we look down here at our Pythagorean triples, and we see, do we have anything with the sides 3 and 4? And I look down here, and here we go, 3 and 4 right here. So this last one should be have a factor of 5 in it and that common factor of 8. So it would be 8 times 5, which equals 40. So that's the second method of solving right triangles with a Pythagorean triple.